Okay, after we have plotted the decision boundary, we are now interested to find whether a student is going to get admitted or not, and we are interested to find whether our prediction that the student is going to get admitted or not is accurate or not. So we will be evaluating the logistic regression. An example has been given here that says that if exam 1 score is 45 and exam 2 score is 85, then the possibility or the probability that the student is going to get admitted is 0.776. Essentially, what that means is when we say we have a hypothesis, we're saying what is the probability that the student is going to get admitted. That was the basis of binary classification. Our hypothesis has to range within 0 and 1. The hypothesis that we have was a sigmoid of theta transpose x, and the sigmoid basically squeezes the possible outcomes between the values 0 and 1. Okay, so what does that mean? Basically, we are saying that if a student has a probability of being on this right side of the sigmoid function, then he is going to get admitted or she is going to get admitted. And if the probability that they're going to be likely on the left side of this sigmoid function, then they're not going to get admitted. Now, this crossover point here, the intercept here, that is at 0.5. Essentially, that means that if our probability that the student is going to get admitted is more than 0.5, then we will classify the student as 1. That is, they are going to get admitted. If it is less than 0.5, then they are not going to get admitted. It is pretty straightforward. What we have to do is state the hypothesis one more time. Here we have it. The hypothesis is the sigmoid of x theta. Now, the probability that each of the students are, the probability that we take into account for each student, whether they're going to get admitted or not, that is going to be a vector p. And the size of the vector p is going to have 100 of the training example and is going to have a single column. The single column is only going to predict whether it's going to be 1 or 0. So we run a for loop. We say that we are going to iterate from the first student to the 100th student. And if our hypothesis of the corresponding student says that it is more than 0.5, then the prediction for that corresponding student is going to be 1, else it is going to be 0. That is as simple as it gets. We can run the program and we will test whether we have been correct or not. So here we have it. For a student with scores 45 and 85, we predict an admission probability of 0.776289. The expected value is 0.775. So this is just our information, just for our reference. Our training accuracy is 89 and the expected accuracy is also 89. What does that look like though? Let us remove the semicolon for the hypothesis and run this code again. Let's see what the output looks like. Okay, so for some reason I did not get the hypothesis here. I should have gotten the hypothesis here. Okay, I'll run it one more time. By the way, hi Boishaki. Okay, let's continue. That is interesting. It's not showing what the hypothesis is. Oh, well, yeah, of course, because I'm taking out the wrong one. I'm taking out the condition one. Okay, third time's a charm. And there we go. So this is the hypothesis we have. So we would be predicting that for the student who got, this is the probability they are not going to get admitted. But somebody who is at 0.99, they should get admitted. So based on the vector that we have produced here, based on these 100 entries, we should expect that our accuracy is 89. Ideally, this should be higher, but why are we not getting it more than 89? Well, we can concretely look at the decision boundary that we have for theta. So these cases, these edge cases, they are the ones that is giving us the wrong answers. Okay, they're not the wrong answers, but they are causing your prediction accuracy to go lower. Remember how I was telling you before that if our decision boundary was a curved one, maybe something like this, maybe that would have been better. Maybe we still would have had a few going over the boundaries, um, but that would have caused the prediction accuracy to go higher than 89. So that is about it, and we shall move on to the next question.